And with that, I'm going to hand it over to Cruz from Truffle to get us kicked off.
All right. Hey everyone, my name's Cruz Molina. I'm a blockchain tools engineer on the Truffle dev team here representing Truffle today.
And my name is Nick Gaski. I handle client and technical enablement here at Kaleido, and we've started working really closely with the Truffle team over the last few months, so excited to demo Truffle working on Kaleido today.
All right, so I'm here to giving a crash course introduction to Truffle, providing some context for Kaleido's integration with our Truffle box system. So I'll be doing an overview of the Truffle suite at large, as well as a CLI crash course, going over some of the key Truffle features, Truffle boxes, compiling your smart contracts, testing, deploying, and a little bit of front-end integration. So let's get to it. Okay, so the overview of Truffle Suite at large is our mission is to get develops from idea to dApp as comfortably as possible. And we do this with a range of tools. There's Truffle CLI, there's Ganache, there's Drizzle, and all of these tools sort of play different roles in the development lifecycle. Oh, and another point is they're all 100% free and open source, hosted on GitHub. And something that recently happened is we hit the 3 million aggregate download mark for all the Truffle Suite products combined, something we're pretty excited about. So who's using Truffle? Who's making all these downloads? We've got, of course, Kaleido, Microsoft, Amazon, JP Morgan, a whole host of big companies that are really helping make Truffle the blockchain development framework that it is. So let's go over the different products, the key ones. So we've got Truffle CLI, which is written in Node.js. It dramatically reduces the complexity of building dApps. We literally just released this morning version 5.0.25, and so I'll be demoing that live. Yeah. And just a little teaser for Truffle in use. You install it globally using Truffle. Here's some example commands. I'll be going over some of these in the crash course shortly. And then a key part of Truffle are Truffle boxes, which are boilerplate projects that are great for demoing proof of concepts, creating and sharing tutorials, kickstarting your dApp projects. And we have officially supported and community boxes highlighted on our website. Okay, so Ganache. Ganache is the personal blockchain for Ethereum development. It creates a local Ethereum network for development and testing. There's two flavors, Ganache UI and Ganache CLI. Something really exciting about Ganache UI is 2.0 allows you to visually explore contract state and events, making it really awesome to visually see what's happening on the blockchain. As opposed to a CLI tool. I won't be going over it in the crash course, but here's a screenshot of Ganache UI in use. Definitely check that out when you have time. And then we have Drizzle, which is our front-end component. It's a React.js library, great for building UIs for dApps. Drizzle really shines in terms of reducing the amount of code that you have to write to get your dApp started. And it's also great for synchronizing your contract state with the blockchain in real time. If you want to see some of that synchronization and some of those features of Drizzle in use, definitely check out our recent tutorial on managing smart contract events when you have time. All right, so let's get into the crash course. So some prerequisites for Truffle, if you're not familiar. You'll need Node.js. You should be familiar with Solidity, which is an EVM-targeted smart contract language. You've got to have NPM, the Node Package Manager, and MetaMask for those who aren't familiar. It's an Ethereum wallet browser plugin. And of course, you need Truffle installed globally using NPM. So let's do that. Here we go. npm install globally, Truffle. And while we're letting that install, I'll go over sort of the introductory command for Truffle, Truffle init. Truffle init quickly gets you set up with a bare bones Truffle project. So now that we have Truffle installed, let's do that. Let's make a new directory. Let's call it Truffle Hello World. We'll change into that directory, and we'll run Truffle init. So what Truffle init does is it downloads a bare bones project and sets it up for you. And so let's explore and see what the basic Truffle project is, the structure. We've got our contracts folder for your contracts, migrations folder for migrations, and of course your test folder for tests. And then also a crucial part of every Truffle project is your Truffle config file, where you can customize your Truffle project to suit your specific needs. Okay, so now that we've gone over init, let's go over the unbox feature and demo a Truffle box. So I'll change back up a step and so we're gonna demo the drizzle box. So let's make a drizzle demo directory, we'll change into it, and let's run Truffle unbox drizzle. And what's really cool about the unbox command is it not just downloads a given Truffle box, but if a Truffle box is so configured, it will run post box installation steps. So right here, you can see it's saying setting up box. Right now, it's installing all the necessary dependencies for the drizzle demo. And while we're waiting for that to get set up, let's dive into another key feature of Truffle, the develop command. We'll do that with Truffle develop. And Truffle develop, what it does is it starts up Ganache, a local private Ganache chain in the background for you, disconnected from a live network. So totally private, and it pops open some 10 accounts for you. They're private keys and they're mnemonic. And these are temporary accounts, so the chain state does not save in between sessions. Okay, so Drizzle's still getting set up. Let's see if our contracts are available. Yes, we have the contracts folder, we have our contracts. So why don't we compile our contracts? Within the Truffle develop context, you'll run the compile command. And of course, what compile does is it compiles your contracts. These are Solidity contracts. And then it outputs them as contract artifact JSONs. And so just to show you real quick what these are like, don't have time to go into all the ins and outs, but here's the contract JSON files. Crucial part of a Truffle project. You really need these files in order to leverage a lot of what Truffle can do for you. So now that we've compiled our files and Drizzle is now successfully unboxed over here, let's test our files. Let's test them before migrating them to the develop chain. So within Truffle develop, we'll run test. And Truffle test, Truffle uses a Mocha.js style framework for testing. So you can write your tests in JavaScript, and you can also write Solidity unit tests. So our tests pass, great. Looks like we're good to go. Let's migrate our contracts. So again, within the Truffle develop context, we'll run migrate. And Truffle migrate, it runs any migration scripts that are located in the migrations file. And migrate outputs you really good information regarding your contract's deployment. So, you're deploying this contract, deploying that contract. It shows you the contract address, the block number, And it even gives you a gas cost of how much it costs to deploy a given contract. So now that we have our contracts migrated to the develop network, let's see if we can connect our front-end component to interact with our blockchain, our contracts. So we'll cd into the app folder, and then we'll run npm run start. So we'll switch over to our browser, connecting to localhost 3000. For this, you'll definitely need MetaMask. There we go, loading. MetaMask is requesting for me to give permission to connect. So I'll give permission. And let's see if we have to refresh. Sometimes MetaMask gets a little clogged up, so let's connect to another network real quick and then back to localhost 8545. There we go. So here's our basic UI powered by Drizzle. And what we'll do to showcase real quickly the power of Drizzle is we'll store a numerical value of 1 into our contract. And this number here should dynamically update. So we'll submit the value, confirm the transaction with MetaMask, and there we go. Stored value of 1. And so that's pretty much Truffle CLI in a nutshell. Going over some key features. There's a ton more to check out, but that's it for now. And I will pass it over to Nick.
Awesome. Thanks for that, Cruz. So again, Nick Gaski here with Kaleido. I'm going to give you a high-level overview of what Kaleido is, and then we'll do a lot of the same tasks that Cruz just demonstrated and get a Truffle Drizzle app running that can actually target the private Kaleido chain. So Kaleido is a full-stack blockchain platform for enterprise permission consortia-grade blockchains. And we have 3 main tenets, so to speak. Built for modern business networks, so industry use case agnostic, radically simple UI and APIs, so developers of all shapes and sizes, even C-suite executives can be comfortable using the platform, creating resources, and built for the enterprise, so hardened, high availability, disaster recovery, etc. Kaleido sits at the intersection of a number of really, really interesting companies. First, Consensus, the world's largest pure-play blockchain company, and we're privileged to work with groups such as Truffle, but also other spokes inside of Consensus, such as OpenLaw, Infura, Rhombus, for example. Kaleido is offered on both the major cloud platforms, Microsoft Azure and AWS, allowing you to have a flexible hybrid deployment scheme in your consortia. So a few things around Kaleido: click button simplicity, flexible configurations, whether that's node clients or consensus algorithms, fully API enabled. So anything that you can do in the dashboard, creating a resource, creating a node, for example, you can do programmatically via the API, and enterprise hardened, knowing that Kaleido is going to persist and stand up all of these resources with automatic failovers and high persistence. So as I mentioned at the beginning, we are multi-cloud, so you can create these hybrid consortia and have one organization exist on Microsoft Azure, for example, another organization exist on AWS. And this is really important because, major enterprises are not willing to migrate their existing IT estates to a new cloud provider. In addition to this flexible cloud deployment, we also offer on-premise nodes. So in a cloud of your choice or in your own data center, you can connect back to a Kaleido consortia blockchain. We emphasize, shared IT and simplified membership onboarding, and we also implement governance at this layer. So we recognize that not all enterprises, not all organizations in the context of a consortia are going to exist on equal footing. Some may need super user permissions, some may need a rescinded level of permissions. Enterprise grade, as I mentioned, so 24/7 support, ISO compliant, automatic failover, Kubernetes, auto scaling, etc., and also the ability to have your own dedicated compute, your own permission VM in one of the targeted cloud providers. So 2019 has been really awesome for Kaleido, as we've seen a number of our major clients accelerate from pilot and proof of concept actually into production. So we can see some major banks here, some energy majors, huge brands, huge retailers, etc. One example of which is a consortia named Comgo, a portmanteau for Commodities Go. And Comgo is digitizing the rather antiquated and heavily paper-based world of commodities trade finance, doing this on Kaleido to streamline processes, remove intermediaries and different parties necessary for reconciliation, and really increasing cash flow. So awesome consortia and awesome demonstration of the power of blockchain. What we've learned, though, as we've worked with these large organizations, is that the actual blockchain layer, the nodes and the smart contracts are a really small portion of an overall solution, right? If we think of what a full stack solution actually looks like, we can see our app at the top where we would do stuff around tokenization, cryptography, enterprise integrations, RESTful gateways. But then we also need lots of middleware, right? We need app-to-app messaging. We need systems for identity masking, user management. We need connectors to our existing back office processes. And then different schemes for storing data on-chain, off-chain, different representations and different integrations of that data. So to accommodate for this plethora of needs, we've created what we call the Kaleido Marketplace. And this is a library of all of that componentry, all of the building blocks that you really need to create enterprise-grade full-stack solution. So this is some proprietary services that we've created, such as a mainnet tether to the Ethereum mainnet, third-party solutions, example, clause for smart contracts and auditing, and then a lot of integrations with some of the hardened cloud services that you can get on an AWS or a Microsoft Azure, whether that's key management, log streaming, storage, etc. And in our marketplace, amongst other things, we also emphasize developer tooling. And so we're going to show you a demo here of Truffle, Ganache, and Drizzle. So let's go for the live demo and cross our fingers that everything works. Okay. So the first call to action when you visit Kaleido is to create your consortia. And the consortia is just going to be a grouping of the business organizations that participate in your permission blockchain network. So we can call this Truffle Demo. And now we need to set a home region. And this is going to be the whitelisted cloud provider where we store some membership data, but it's also going to be a whitelisted region where we can deploy nodes and we can deploy resources. So this is going to host our actual blockchain. So we'll make Microsoft Azure our home region. And now we could turn this into an actual cross-cloud hybrid blockchain by whitelisting AWS and certain regions in there. For the sake of simplicity in this demo, we'll stick solely with Microsoft Azure here. So this gives us the baseline scaffolding of a consortia. My organization is organization ABC, and I'm provisioned as the first membership. And now we want to set up an environment. We want to bring this blockchain to life. So in Kaleido, every environment is its own unique instance of a blockchain. So all nodes, all resources are firewalled and encapsulated within an environment. And in a consortia, obviously, you can have multiple environments. So we have Microsoft Azure as our only whitelisted region. So that's going to be our only choice at this point. So we'll go ahead and click next. We can configure our protocol and our consensus algorithm, choosing between Geth, Quorum for private transactions, and Pantheon, the newly released Apache licensed modular Java-based client from the Pegasus team here at Consensus. I imagine most people are familiar with Geth, sort of the battle-hardened version out on the mainnet. So we'll go with Geth and POA for our environment here. So now we have a namespace. We have an empty namespace, and we want to bring it to life by creating some nodes and actually instantiating our blockchain. So we'll go ahead and add our first node, call it node number 1. We can optionally choose to weave in some of these native cloud services like key management, backups, or log streams. That's a bit of heavy lifting, so we'll forego that for the time being. And then we can choose the node size based on the performance and sort of concurrent connections that we anticipate in our network. We just need a small node for this. So we have a single node. I'll go ahead and add one more to make our POA algorithm happy. Call it node 2. And go ahead and finish that. So as these guys are coming to life, let me go back to our actual consortia layer and draw your attention to 2 important things. So what we have here is we have an ostensible, or we have an asserted identity. And for know your customer requirements or anti-money laundering, what we really need to do is we need to weave in some trust paradigm. And what we allow you to do on Kaleido is to underpin this asserted identity with a PKI-backed X509 digital certificate. So you can marry your ostensible identity with an actual identity proof. And this would allow the rest of the consortia to download, parse, and inspect that certificate. This is a lightweight consortia that we have here with a single organization, so sort of unnecessary for this type of orchestration. But if you imagine, a Congo, for instance, where you have, dozens of organizations, those requirements become really, really important. So we'll go back to our environment, and we see that we have our 2 nodes on Microsoft Azure that have come to life. So now we want to talk to our nodes and weave in Truffle here. So we click our node, and we see a lot of the low-level details and resource IDs, and we also see this connect button here. And this is going to open our Kaleido Connect service. There's two doors we can go through here for this. The first is the native JSON RPC interface, where you would use a common Web3 library, you'd use one of the lovely development frameworks like Truffle. The alternate route is a Kafka-backed REST API gateway. And this is a service that actually abstracts the core Ethereum API and lets you send really, really simple REST calls for reliable delivery to your blockchain. And this is fantastic for transaction simplicity because it allows you to have lightweight YAML and JSON payloads rather than complex Ethereum transaction objects. So we're going to generate some application credentials. These are strongly generated credentials that give us secure TLS access to the ingress. We do salt hash verification on the back end with these. And now we see that we have a lot of different methods that we can use to talk to the chain. So we have fully baked code samples for 5 of the popular libraries, and we also have our Truffle suite configuration here. And we supply out of the box the actual configuration strings that you need that we're going to put into our Truffle config file to securely connect to Kaleido. So we can click on the drizzle box, and this is going to give us a set of instructions that we need to follow. So I've already done this in my terminal, so I'll open up terminal land and we'll take a look at this on Kaleido. So I have a directory called Truffle Drizzle. I'll open that up in Atom or VS Code or whatever your favorite editor is, and we see a similar structure that Cruz demonstrated here. One important thing to note that when you're unboxing this project, it's not only going to create you the directory structure and all the files, but it's going to install those dependencies. So it's going to give you the Web3 library. It's going to give you those React modules that you need for Drizzle. Okay, so we have our app here. This will be the Drizzle component, and then we have our contracts. We're going to use a contract called Simple Storage, and it truly is as simple as a contract can get. It has one global variable and one function, to set that global variable, and then there's an event called storage set that will be emitted every time this method is called. Okay. More interestingly, we want to look at our Truffle config file, and this is how we're going to securely connect to Kaleido. And we see that there's two parameters that we need to provide here. We need our app credential, and we need the endpoint of the node that we're going to target. So if I return to our Truffle screen inside of Kaleido, I can grab these values. So we'll grab our application credential, and we'll replace the placeholder with that. And then we'll grab our endpoint and replace the placeholder with that. And we see that using these two strings right here, we're going to actually construct the appropriate fully qualified URL that can be passed to, one of these provider APIs right here. Okay, so let's go ahead and save this. And now we can go with those basic commands that Cruz demonstrated in the Truffle development module. One thing to note also, if you're using Kaleido, if you want to have a network, an environment that's using Quorum, Raft, or IBFT for the algorithms, you need to uncomment this, this type variable here to let Truffle know that it is a Quorum network. Okay. So we'll open Truffle develop, and we'll try out those same three commands that Cruz demonstrated. So we'll go for compile. We will go for test. And this is just letting us know that our box is properly configured, right? That we have proper, Solidity code that can compile down to, the EVM compatible bytecode. And that we have strong test programs testing what we actually want our contracts to do. So those both passed, and lastly, we can do a migrate. Great, so that worked. And now we can do an exit, and we can actually deploy this to Kaleido. So once again, say Truffle migrate, and using our config, this should ideally hook into our Kaleido network and instantiate our two smart contracts, our migrations Solidity smart contract and our simple storage smart contract. And the Truffle interface is really nice here, right? It provides you with some really interesting information about what's going on with each of these transactions. So those both came through successfully. So now we can return to Kaleido, and we should see a total of 4 transactions. 2 smart contract instantiations, and then 2 invocations of our migration smart contract. So if we go back to our environment that I named development, and we view our block explorer, we see those 4 transactions here, right? So here's our instantiation of the migration smart contract. Here's the invocation of it. Here's the instantiation of simple storage. And here's another invocation of the migration smart contract. Okay, so lastly, we will spin up our Drizzle app, and we'll send one final transaction to the blockchain. So going back into my node, I'll go through the connect interface again, regenerate some credentials. And these credentials are ephemeral, so a smart practice is to save them. We give you a really convenient regenerate button, so I've grown into the habit of doing that. Okay, so before we start our app, similar to what Cruz demonstrated, we need to tell MetaMask about the network that we're targeting. MetaMask is going to sign this transaction for us when we're using our Drizzle app. So we go into MetaMask, and I will do a full screen mode for you. Okay, and we want to create a custom RPC network here. Okay, and this is where that string that I just copied from Kaleido, this string right here, this is what we want to actually input as our custom URL. So let me make sure I have this on the clipboard. Okay, so we can paste this guy and then give it some friendly name, right? My Kaleido chain. Click save, and now we can see that MetaMask is securely connected to Kaleido. Awesome. Okay, so the last piece here is now we want to spin up our app. So we'll change into our app folder. Let me try to move this zoom Okay, cd app and npm run start. Okay, so this is going to use localhost port 3000, and this can take upwards of 20 to 30 seconds for the actual app framework to manifest on your machine. So cross your fingers, be patient at this point, hope that it works. Okay, so it did work. We were confident. And the last thing we want to do is we want to increment this value right here, right? Just what Cruz showed. He did 1, I'm going to do 5 instead. Okay, so we'll submit that. Our gas price is 0 in Kaleido. Obviously, you can configure this to actually charge Ether. It's imaginary Ether in the scope of a private network, but we have a utility called the Ether pool, which actually gives you 1 billion Ether in the Genesis block of every environment. So if you wanted to enforce smart contract fees or actually map that called imaginary Ether to fiat or some actual tangible currency or tangible value, you could do that and integrate that with your smart contract. So we'll click confirm, and we should see a notification from MetaMask when that block is actually cut and the transaction is executed. Maybe I should turn Slack off. Okay, that took a little longer than we expected. This is a Geth POA environment, although Cruz showed the fickleness of MetaMask from time to time. But we do see an auto refresh of our stored value here, changed to 5. And so now we could return to our Kaleido environment, check our block explorer one more time, and we should see a 5th transaction in our environment. And we do. We see the invocation of the set method inside of simple storage. So that's a really lightweight run through of using Truffle and using Kaleido, but hopefully this gave you not only a good idea of how easy it is to download and unbox one of these pre-baked Truffle boxes with front ends built in, but also how to get started building your first Kaleido environment, choosing your cloud, choosing your different configuration. So I will stop sharing, and I think we can take some questions at this point.
So we have one question in the chat there, Nick. Will this work with Viper when it becomes more widely in use?
Yeah, I mean, the only requirement is, proper compatibility down to our compilation down to the EVM. So yes, this would work with Viper as well.
I can speak to that question a little more directly. As of Truffle version 5, we support Viper compilations. You have to have a Viper installed locally on your machine. I don't think the compiler has been ported to JavaScript, but as long as you have it on your machine and you have some Viper contracts in your contracts folder, Truffle should compile them.
Thanks. Next question is, how do I get Kaleido on premise?
Yep, so we're currently piloting on-premise nodes with a number of clients. So the best thing to do would be to either use the contact us feature within Kaleido or to email directly info@kaleido.io.
Awesome. Cool. Another question for you, Nick, is what are the advantages of hosting your own nodes versus having them hosted by Kaleido?
Yeah, so that's a great question. There's a lot of, I guess, a lot of maintenance and a lot of sysadmin level responsibility if you truly do want to host this node on-prem. There's a litany of things that could potentially go wrong in terms of tunneling, in terms of routing, and in terms of just the basic communication. So while we're doing this, we are providing a fully packaged set of software to make that a lot easier. I think the advantage, though, is really you want single locality of critical signing materials, critical data, sensitive information, right? So you have your existing data center, you have your existing IT estate, which you perhaps don't want to do, or a risk officer might not sign off on, is being able to migrate and host that up in a cloud. So I think it's more of a compliance and risk conversation based off of existing business mandates and organizational processes.
Perfect. Thanks, Nick. And then next one here is how many transactions a second can Kafka-based process?
Yeah, that's a good question. So there's two ways to do it, right? You can stream directly synchronous messaging via Kafka, or you can use the webhook that we front in the node. And this is essentially going to allow you to get as many transactions into the block based off of the transaction size limit and the target gas limit configured. But we've seen different orchestrations where, if you have a clever horizontally scaled application, you can get, I don't want to put my foot in my mouth, but you can get upwards of in the hundreds of transactions into a block at a time on Kaleido.
Perfect. And then we have another question from Ben asking about the Kaleido pricing model. I actually directed him to your website where it says pricing, but it says contact you. I'm actually not super familiar with your pricing model. I'm actually from Truffle. So Nick or Carolina, if you have an answer for that.
I'm sorry,
What's the Kaleido pricing model?
Oh, I see. Yeah. Good question. Yeah. So it's a software as a service pricing model where you're billed hourly for the runtime of the components and the services that you stand up, right? So these would include, nodes, obviously, but also different services. For example, IPFS nodes, HD wallets, things like that. The mainnet tether service.
Perfect. This isn't a question, but just a kudos for Bron Martinez. He just said, I just want to say great work and look forward to further exploration and experimentation. So thanks for that, Ron. Rich G, he's asking, what are good recommendations for storing off-chain data?
Yeah, so there's a couple ways you can do it. One feature that we're about to release here is it's a document store service that basically leverages our Kafka pipes to securely transmit encrypted messages from party A to party B, and then to either store those in Azure Blob Storage, AWS S3, or a Kaleido hosted storage. So you can use that, and on-chain just use a hash pointer to that data. Alternatively, you can use IPFS nodes, right? So this is a really censorship-resistant, convenient way to do peer-to-peer file sharing with sharding of those files. And once again, you can either reference the parent hash of that file, or you can reference an actual hash of one of the shards. So there's a number of interesting techniques to keep sensitive or high volume large data off the chain, but still point to it on chain.
Perfect. More questions for you, Nick. No breaks for you. Do you have, okay, so what are the methods and ways to store private keys that Kaleido supports?
Yeah, good question. So obviously you can use the node to sign transactions. So we give you a default user account on every node, but you also have the ability to get attached to your node, and you can create multiple accounts on the node, supply your own passphrase to lock those accounts and unlock them on a need-by-need basis. So on your client side, on your Web3 application, you just specify the index of the account that you're targeting and supply that passphrase to use that to sign. Alternatively, you can always, assemble, an externally signed transaction using your own private wallet, your private key store. The only requirement is that you actually have that fully qualified URL that you can talk to the node, or you can talk to the chain via the webhook or via Kafka. There's some really, really interesting services that we are continuing to develop. One is this ETH wallet service, and if you use Pantheon actually has a modular component called ETH Signer that proxies transactions up to the node for execution. And what we've done with Microsoft Azure, with AWS, that actually support the Ethereum curve, SecP 256K1, is you can weave that component in with a key management service, right? So now we can actually let a hardware security module on this cloud provider sign those transaction objects, and you have full trust in the fact that no one can access those critical private signing keys. Lastly, we have the HD wallet service as well, that you can call that endpoint to return you a fully signed transaction object. So there's a nice mix of flexible ways that you can actually construct what you need to submit to the chain.
Okay, perfect. So we have 3 more questions left, so we have about 4 more minutes left on this webinar. Can you also demo for Kafka-based systems like this?
Yeah, of course. I think that would be a wonderful webinar to do, actually, is to dig a little deeper into that REST gateway that we've built. It has a wonderful smart contract API service embedded in it as well, where we'll generate you open API specification and a dynamic Swagger console. So it'll take the ABI for a smart contract. It's going to give you a RESTful endpoint for every one of those methods. So now when you're developing, your application, you just chuck a Swagger client into it, and you can speak, simple REST to these endpoints. So really, really nice. I think that'd be an awesome demo.
Perfect. And then how well does Kaleido handle bulk uploads, example 100,000 records at a time?
Yeah, so again, I think there's correct ways to do transactions in the blockchain world, and there's certain untenable methods. Based on the size of the node that you choose and how clever you are when you're submitting these transactions, as I mentioned, there are methods to get a lot of transactions in the block at a time. However, using Kafka is really wonderful here, and we could do a whole talk on Kafka. Kafka is going to logically inject those transactions at the optimal rate so that they don't fall into a queue transaction pool, so you don't have problems with nonce management. So if you have sudden surges or spikes in workflow, and all of a sudden you need to hit the network with 1,000 or 100K transactions, which that's quite a few. Those will be processed at an optimal rate. So using that method, there is an accommodation for that.
Okay, thank you so much, Nick, and thank you, Cruz, for your time today. Given we only have a minute left, we're not going to be able to answer all the rest of the questions, but you can reach Truffle at inquiry@trufflesuite.com. And then where's a great place for attendees to ask questions to Kaleido?
Yeah, so I guess I should mention that Kaleido has a perpetually free starter plan where you can go ahead and spin up your nodes, and you can go experiment with this REST gateway that we seem to be talking about a lot now. Inside of the product, there's a contact us button. You can also reach us at info@kaleido.io.
Awesome, thank you so much. And we'd also like to invite everyone out to TruffleCon August 2nd through the 4th. It's going to be in Redmond, Washington. We have 60 speakers there. Nick and Cruz are both going to be there as well to help with any questions that you may have. Tickets are only $99 for all 3 days. So it's a heck of a deal. You'll get, again, 60 speakers. We have 50 sessions going on. Here's this, you can see the slide here, a taste of some of the scheduled talks are how to build a secure smart contract with Jocelyn Feist from Trail of Bits, dApp development for the rest of us, which from Adrian Lee, he works on Drizzle, and then of course Nick's talk with the Truffle dev team on how to use Truffle and Kaleido together. So if you just want to pop into the chat right there, there's a link to buy your tickets. So thank you again, everybody. We will send out the recording. Hope everyone has a great rest of their week. Thank you.